In this video, we're going to look at how to use the distributive property to solve problems. So for example, 2 times 3 plus 4, parentheses, and we can follow the order of operations. And first we do, so if you remember, it's PEMDAS. So multiplication, division have the same priority. Addition, subtraction have the same priority. So we first follow the order. We have to work out what's in the parentheses, which is 3 plus 4. So that gives us 7. And between the number 2 and 7, there's nothing, but we have to carry down the operation between right after 2, and that was multiplication. Again, if there's nothing, and it's multiplication. So it's 2 times 7, and that gives us 14. But the other way to do the problem is with the 2 in front of the parentheses or after the parentheses. And imagine the parentheses being a box. So we have 2 items in there, 3 and 4. Say 3 bananas, 4 apples. And this 2 in front of the box means 2 times, which means double. So you're going to double everything in your box. And how do we double everything in the box? We can double the first item, so 2 times 3, which is doubling the first number 3. And then we can double the second number in the box, which is 4, so 2 times 4. And this, as you can see, when we double 3 and double 4, and that is kind of like distributing 2, like I'm distributing 2 to 3, and then I'm distributing 2 to 4. And so we get 2 times 3 and 2 times 4. So again, 2 times, if you think of it as doubling, so it's doubling 3, doubling 4. And between 3 and 4, these two numbers, there was a plus sign. So we're going to keep the plus sign there between them. So first we're going to double each number. So we got doubling 3, we got 6, doubling 4, we got 8. And then we're going to add them, and you can see we get exactly the same answer, 14. So these two methods are both correct. The first method is following the order of operation. The second method is using something, the property which is called a distributive property. Okay, so when we simplify expressions involving variables, we actually have to use the distributive property because the first method will not work. So let's take a look at this example. 2 times 3a plus 4b. Now, if we try to follow the order of operation, we're supposed to combine 3a plus 4b to get something. Now, with numbers 3 and 4, we can combine them to get 7, a single number 7, and then double 7. But 3a plus 4b, unfortunately, cannot be combined into one thing. And again, 3a means, think of it as 3 apples, and plus 4b, think of b, if b represents bananas. And so if we have 3 apples plus 4 bananas and 4 bananas in a box, we cannot really combine them into 7 or something. So we're going to have to leave them as 3a plus 4b. So for algebraic expressions, if the letters don't match, that means they represent different items, different units, different items. They cannot be added together. So we have to just leave them as 3a plus 4b. So the first method doesn't work anymore because 3a plus 4b cannot be combined into 7 of something. But the second method works. So we can double. If we want to double everything in the box, we can first double 3 apples. So 2 times 3 apples, that gives us 6 apples. And then we're going to double 4 bananas. So 2 times 4 bananas, that gives us 8 bananas. So we have 6a plus 8b. Again, these two, 6 apples and 8 bananas cannot be combined, cannot be added because they are different objects or different units. So we have to stop there. So now we're going to use the distributive property to simplify algebraic expressions. So in the first one here, we have 12xy minus 8 minus 17xy minus 5. So when we look at the problem, so the first step is you're going to try to find like terms. When we say like terms, that means they look alike. So for example, x and y, they represent the same thing. And whether they represent apples or bananas, if they look, they're both xy and xy, that means they must match. They must be the same item, same object. So these two, but mathematically we call them like terms. The number in front of them don't have to be the same because they just tell us the quantity. And so, for example, I have 12 of this and 17 of that, and then we can either add them or subtract them. For numbers, of course, we can always add them or subtract them. And what we need to be careful is we have sign numbers here, integers. So we have to remember to use the rules we learned. Okay, so the first step here, that can be omitted. But so what I did is I put these two together, the like terms. These two are like terms together. And notice -8 and -5, they are like terms. I put them together. So that's a little easier for us to see, but you don't have to do that. You may be able to skip the step if you can see that. Do that in your mind. Okay, so now how do we subtract the 17xy from 12xy? So you can think of this xy as like a dollar sign. So if you have $12 minus $17, what would be the answer? So of course, the dollar sign will not change. So you will get the dollar. But what you need to do is you have to take 17 away from 12. So that's what I put in here. And 12 minus 17, if you think of it as money, you're going to be, if you have $12, but you spend $17, you're going to be $5 in debt, which means it's -5 and dollars. But of course, and we don't really have the, we didn't really use the symbol. It's not really the dollar symbol. What we have is xy. So we have to keep xy from the beginning to the end. So you just think of xy as like either dollar sign or like a stuffed animal. So if you have 12 of this minus 17 of that, you would be five of them in debt, 5 of that quantity in debt. Again, 12 minus 17. If you have trouble doing that way, you could put a little plus sign in front of -17. So you will be doing $12 credit plus $17 debt, because we have more debt than credit. So that's why the answer is going to be debt. And how much more debt than credit? 17 minus 12, that gives us 5. Okay, now, so right here, make sure you refresh your memories about the sign number rules. Now, similarly for -8 minus 5, so it's kind of like you have $8. You have -$8, so you're already in debt. If you spend more money, and you're going to be more in debt, which is -13. The other way to do that, this is you can put a plus sign in between the two numbers, and then so you're doing $8 debt plus $5 debt together gives us $13 debt. Because debt plus debt is still debt. And we have the minus sign for debt, and then combine the two debts, $8 plus 5, that gives us 13. Okay, so the second example, we do have to use the distributive property because we have a bunch of parentheses. So in order to get rid of parentheses, and remember this example here, we can distribute whatever in front of it to what's inside the box, the parentheses. So I use two different colors because we have two boxes. So for the first box, I use the red color. So there's just a minus sign. So you can just distribute the minus sign to each one of them in the box. So you have -x, and this minus sign in front of -4. So be very careful here. So when we distribute, of course, we just put the minus sign in front of both of them. So you put this minus in front of x, you get a -x. But when we put minus sign in front of the second item already has a minus sign, which is -4 here. So we have to put this minus sign outside the box in front of the other minus sign, which was inside a box. All right, so now that's how we get this. Similarly, for the second box, we have to distribute the 3 to both of them. So we're going to get triple x, 3 times x. We're going to triple negative 8. So this minus sign goes with 8. So triple negative 8. So we got 3 times negative 8. And between them, I used the plus sign here. And the other way, if you want to do is, you could say, I'm going to triple 8 and leave the minus sign in front of it. So you could do 3 times x. Just keep this minus sign. So instead of triple negative 8, you're going to just triple 8, because you already have the minus sign brought down. But both of them will give us the same answer. So now let's look at here. Notice what we talked about previously. When we have a minus sign in front of minus sign, this literally means what's the opposite of negative 4. So of course it's plus 4. So when you see minus in front of another minus, that turns that into plus 4. Now 3x, there's nothing we can do, bring it down. Now positive 3 times negative 8, we talked about at the rule. We're going to positive times negative is negative. 3 times 8 is 24. Okay, so so the first step we did here was to distribute. So we distributed the minus sign to both of them, then we distribute a positive 3 to both of them. After that, we simplify as much as we can. So for example, 2 negatives make positive, and positive 3 times negative 8 is negative 24. Now, in the final step, we're going to do something like we did here in the first example. So we look for the like terms. Again, like terms mean they look like. If they both have x represents the same number, so we can combine them. If they're both numbers, 4 and negative 24, they can be combined. So negative x plus 3x. Again, think of this as negative 1. Negative x means there's not a number in front of x, that the 1 is omitted. So you can think of this as negative 1x plus 3x. And negative 1, again, if x confuses you, change that to a dollar sign. So you're negative $1 plus $3, and that gives us $2, because we have more credit than debt. So $2 more credit. But again, you have to use the symbol they gave you instead of dollar sign. But the idea is the same. Whether it's x here, you bring down x. So you don't really do anything to x. Just you only deal with the numbers in front of them. And then 4 minus 24, that gives us negative 20. So again, how to do 4 minus 24? You can put a little plus sign in front of between them. So we have $24 debt and $4 credit, and we have much more debt than credit. So the answer is going to be in debt. And how much more? 20 minus 4, $20 more debt. And when we get here, we cannot really do 2 minus 20 because they're not like terms. So we cannot simplify any further. It's kind of like x is one item, but 20 is something else. Because 20 just means the number 20, but 2x means $2 or 2 bananas. So we cannot really do 2 bananas minus 20, a number 20. So in order to add or subtract, we have to make sure they are like terms. Now in this example, we're going to be doing something very similar to what we did, but we just have 3 pair of parentheses. So first step, we distribute negative 5 to everything inside the parentheses. So you see I have negative 5a and negative 5 times 3. And then next, we distribute 3 to everything inside the parentheses. It's positive 3. So positive 3 times a plus positive 3 times 7. And finally, we distribute the negative 4. So negative 4, put it in front of a, and negative 4, put it in front of negative 4. After we finish distributing, we can simplify each one of them. So we have negative 5. Negative 5 times 3 is negative 15, plus 3a, plus 3 times 7 is 21. Negative 4a, negative 4 times negative 4, 2 negatives make a positive. So I got positive 16. Now we're going to look for like terms to combine. So for example, all the a's can be combined, and all the numbers can be combined. So I put them together. And finally, we are going to take the A out, leave it, and we're just going to add or subtract the numbers in front of them. So it's -5 plus 3 minus 4, and which gives us -6. And -15 plus 21 plus 16. So I first do -15 plus 21, that gives me 6, and 6 plus 16, that gives me 22. So if you have trouble doing -5 plus 3 minus 4, slow down. -5 plus 3, that gives us -2, because more debt than credit, $2 more debt. And then -4 minus -2 minus 4, it's $2 debt plus $4 debt, that gives a -6. So that's how I got that. Same thing here. More credit than debt, $6 more credit. Credit plus credit is $22 credit.